Today, I'm going to show how to do a voltage drop test, which is useful in finding why we have no current or low current flow in electrical systems, often causing problems with the charging system, headlight system, or cranking the engine over when we try to start the engine. There could be all kinds of other issues, but I want to show at least the basics. And this can be applied to any electrical system, whether it's headlights, taillights, brake lights, turn signals, dome lights, anything that carries any kind of load that is behaving unusually. To begin, I'm going to disconnect the start and ignition small terminals from the starter relay on this 1973 Mach 1 Mustang. And I'll be connecting a remote starter button to crank the engine over while reading voltage drop values between connections. The connection could be somewhere as close as battery post to battery terminal, or negative terminal to engine ground, anywhere in between. And the rule of thumb is we want to see as low a voltage drop reading as possible between the two areas being tested. So between the battery post and the battery positive flood terminal, when I measure across here for voltage drop, I don't want to see any more than 1/10 of a volt. If I measure between the negative battery post and engine ground, I really don't want to see more than 3/10 of a volt drop. Now, I haven't done this on this particular vehicle yet. I do have one area where there's a potential for a voltage drop, but I'll go over that a little later in this video. So for right now, I have Linda do a video recording of me testing the drop as I'm measuring and cranking the engine over. Because during the cranking of the engine, if there is voltage drop, it'll show up on an active current. What I'm going to be using is a handheld digital volt ohm meter with a clamp amp. This is called a clamp amp because this clamp goes around to do the voltage drop testing and an amperage draw test. Is a handheld digital volt ohm meter with what's called an amp clamp. And what the amp clamp does is it clamps around a wire, and when current is running through this wire, electromagnetic waves will cause this to pick up a reading and display down here how many amps or milliamps we have flowing. And this clamp amp can handle up to 400 amps of current. So it'll be plenty for me to test the starter motor draw of this engine. Now, in order to do the testing, I have a remote start button hooked up to the starter relay, and I have unplugged the vehicle starter circuit and ignition bypass circuit. Otherwise, when I crank it over, it's going to try to start. I don't want that. I just want to crank, nothing else. So before I test anything else, I'm going to turn the clamp amp on to 400 amps. And down here, it shows that I am in the DC mode. If I want to change that, I hit the function button. Now it's an AC current. I want DC current. So I hit that again until it once again shows DC current. Now here it's showing 0.2 of an amp is flowing. Well, it's not. So I have to zero this out. So each of these units has a zero button somewhere. Press and hold down until this goes to zero. Now, in order to read how many amps the starter motor is drawing, I clamp this around the starter motor cable. Or if I am after it's a general reading, the negative cable. Now, when I hit this remote button, the engine is going to start to crank. This will spike and then it'll come down. I'm looking for 250 or 200, 180 amps, depends upon how the starter motor is set up and how good the circuit is. Let me see if I can get this with a light. There. I'll have to review the video to see what the amperage was. Okay, I reviewed the video showing how many amps were coming across while I was cranking the engine. And I saw like 159, 161. So not as high as I would have expected, but from the sound of how well the engine cranked over, it did fine. So I'm not worried about the cranking amperage being too low. If it were very low and the engine was having a hard time cranking over or wasn't cranking over, I would suspect a bad connection somewhere in the starter motor cranking circuit, which could be as simple as either or both of the battery terminals, a ground terminal, the battery cable from the relay down to the starter motor, anywhere in there, or inside the starter motor itself, with worn brushes that aren't contacting the armature inside the starter motor properly. Anything like that could cause a high resistance circuit, which would cause a low amperage reading, along with the engine either not cranking over or cranking very slowly. So now I'm going to go ahead and move on to performing an actual voltage drop test. Okay. So what I'm going to do is move the selector from the off position down to the voltage position. Instead of amperes, I want volts. And right now it shows 0.1 to 0.3 millivolt, which is like 0.0003 or 0.0001 volt, almost nothing. Now it is still floating a little bit, and that happens with very sensitive equipment, and that's why they have the zero function where I can hold this down and and zero it. There we go. But as you'll see, it'll still float around. If I touch both of these leads on the test leads, I'm putting out 145 or so millivolts of DC current on my body. So I'm not too worried about it being 1.1 millivolts or something like that. I'm after bigger readings than that. So first, I'll check the battery itself and see how many volts it's putting out. And here, I go to the center of the positive post, the center of the negative post, and what's your reading?
12.43.
12.43 volts. Okay. My first voltage drop area I'm going to test is going to be the positive battery terminal and positive post. So I put my terminals on each of those. I'll turn this light on so I can see what's going on, and then I'll crank the engine.
Up to 0.6 or 0.06.
Okay.
0.6.
0.6 millivolt, which is way, way, way less than 1/10 of a volt. So we're good there. Now, you can't really do a voltage drop test on a circuit accurately unless there's current flowing, which is why I was cranking the engine over. I could have simply opened up the car door and had the dome light come on and let that current measure that voltage drop. But I'm doing this with the starter motor for another reason. So now I'll move over to the negative battery post and negative battery terminal. And I'll crank the engine and see what we got there. Okay, 1.3 millivolt, which is 0.0013 volt, way less than 0.1 volt. So we're good so far. Now I'm going to check between the negative battery post and this piece of metal, which is grounded to unibody through the radiator support. This is going to be kind of tricky. And this has a total of 1, 2, 3 connections at least. So I want no more than 0.3 of a volt voltage drop.
$182.
Okay. $182 millivolt, which is 0.0182. So that's a very, very low voltage drop. So if that's a good connection between here and the shell of the automobile. Now the other place I can check is between the battery post negative and a ground on the engine, such as the alternator.
$168.
About the same? Okay. So that tells me that even under cranking load, 150 or so amperes, we're only experiencing 0.16 some odd volts, a voltage drop. So that's really good. Another place I can check is between the positive terminal on the starter relay and the positive post of the battery. Times like this, I wish I had 3 hands.
Is the highest.
Okay, I'm gonna stop the recording and look at the video and see if that's 141 or 1.41. Okay, I reviewed the voltage drop from the positive battery cable to the positive terminal on the starter relay, and in the frame that I saw, we had 133.3 millivolt, which is 0.0133. I would be okay with 0.2 volts or higher, which would be 0.2 millivolt. So we're well within spec. But now I'm going to have Linda record me going from the starter relay, positive cable and negative cable, to see what the voltage is before and during cranking. When we set the handheld unit up to measure volts, I go to volts and I'm looking for DC. Now I can change that mode to AC, to megahertz if I want to measure vibration. I'm right back in DC. And then I want to zero this out by holding down the zero function. It's gone to 0. And now I'm going to go ahead and connect the voltmeter, crank the engine, and measure and cut. So I'm going to put the negative test lead on the large battery cable terminal that goes down to the starter motor, and the red lead to the positive side of the starter relay. And you see I have 12.44 volts, which is battery voltage. The reason for that is because this is picking up the voltage from the battery. This is showing how many volts I'm seeing at the other end, and it's showing a complete circuit so I can see the voltage, because this large battery cable to the starter is sending current through the brushes inside the starter, so it completes the circuit. If I only touch the red terminal and not the black one, we essentially have 0 volts. So what I'm going to do is I'm going to touch these two where I'm getting battery voltage, because it is sending something, and then I crank the engine over, and then I want to see how many volts we have coming through. And what that will show is how much voltage drop we're getting across the copper disc.
Want me to push the start button?
Yeah, you go ahead and hold this one. Oh, yeah, that's fine. One moment.
So we're at,
Let me get the light on. Linda is going to hit the start button right now. Okay, so I'm getting what looked like 0.068 volts droppage, millivolt. So we're getting good continuity across the starter relay. Now, if during the cranking it kept reading battery voltage, that would indicate that inside the starter relay there's a copper disc. When the engine cranks, it gets shoved up against two terminals. If either or both of those terminals don't connect to that copper disc properly, it can cause resistance. It can even stop current from flowing to the starter altogether. So that's why that part is an important test. And there's other things you can do. You can go ahead and put one terminal on the alternator output, the other test terminal lead to the positive lead of the battery while the engine is running. And while the alternator is charging the battery, you can see how much voltage drop there is between those two locations. It should not be more than 0.2 of a volt, 0.1 of a volt drop per connection. Or if we had a cranking problem on the negative cable on these Mustangs, 1973 back to 1966, the battery cable has the end that bolts to the engine or the cylinder head, one that bolts to the negative terminal post on the battery, but in the middle, part way, there's a metal tab that is attached to the metal cable itself, and there's a hole in that tab, and we're supposed to see a bolt going through that hole holding that tab against the inner fender of the car. And that's what gives the unibody and all the electrical connections in the car and the headlights and taillights a common ground that goes back to the battery. It also provides a good ground path between the unibody and the engine itself. So when the engine is being started and cranking over, the voltage and amperes being sent to the starter motor goes through the starter motor and then through some brushes and then to ground. That ground would be its connection to the engine. And the flow back to the battery would be through that ground cable that is connected to the engine block and then connected to the unibody as well as connected to the battery itself. It really takes all 3 points of contact for a good ground between battery, the shell and frame, if you have a frame of a car, and the engine. As far as how many places you can measure voltage drop, the sky is the limit. Anywhere you see current flowing, you measure at a location where the current is coming into a device and back out the device. Even something as simple as, I'll put this on the alternator output and this on the engine and make sure I have either low drop or in that case high voltage, because you don't want it to be directly connected to ground. You want that going to the battery. But you can check anywhere along the positive cable between the alternator and the battery. So if you have a charging problem, you can check for high resistance anywhere along the way. And especially in a car like this, where I've done a lot of custom wiring, it's important to understand how to do a voltage drop test. So if something is acting unusual, I can go ahead and check for dynamic continuity using a voltage drop test, knowing what I should be seeing as opposed to what I am seeing, to identify the cause of a problem and then solve it.